Just before we jump into our unit on solving exponentials and logarithmic equations, I thought we should take a look at a couple of prerequisite skills. I'm not going to make a video to demonstrate all of them. Most of them are things that we've covered in the not too distant past or are things that I think are pretty straightforward from earlier grades. There is, however, a couple of things that I do want to take a look at. So let's go to that now. Specifically, what I want to take a look at is simplifying radicals. And just a reminder that radical is just another name for roots, specifically square roots or cubed roots, etc. Whatever root we're dealing with. We're going to focus mostly on just the square roots for now because first of all, they come up the most frequently, and second of all, they're the skill that we're actually going to be using in this unit. So for number one, simplify each of the following radical expressions. Root 50, we could easily right now plug that into our calculator, but we can also manipulate it a little bit to make it easier to work with. So what I want you to do is look at that number and ask yourself, what's the biggest perfect square that I could divide 50 by? So I could try things like 4, 9, 16, 25, 36, etc., all the perfect squares. And I think that you'll see that this is going to be divisible by 25. Now, normally I wouldn't write these extra steps in here, but I will for now, just for this one example. I can rewrite the root of 50 as the root of 25 times 2. And then I can actually separate those into separate roots. And since 25 is a perfect square, I can take the square root of it, and that simplifies down to 5 root 2. Now this should be something you did in grade 11, but it's something that you probably didn't spend a lot of time on. It doesn't come up in a lot of different topics, like things like exponents and quadratics do. So that's why we're going over these basic ones today. For the next one, 3 square root of 1280. Okay, so now let's check 1280 for perfect squares. Is it divisible by 4? It is. Is it divisible by 9? I don't think so. Is it divisible by 16? And I believe it is. And what I can do is I can keep checking on a whole bunch of different things. So I'm just going to say this is equal to 3 root 16, because 16 is one of the factors in there. I'm not sure if it's the only one. And I'm going to do 1280 divided by 16, and I'm left with root 80. So root 16 times root 80 is root 1280. Okay, now I'm going to just point out that once we're done that, we should look and see if we can pull any other perfect squares out. Can I pull any perfect squares out of 80? I can pull out a 4. I still can't pull out a 9. If I couldn't before, I can't now. And actually, I think I can pull another root 16 out of there. And when I divide 80 by 16, I get 5. Now 5, I think, is the end of the line. It's not a perfect square, and it's not divisible by a perfect square. I know that because it's prime. Always interruptions. So now what I can do is I can say that's equal to 3 times 4 times 4 root 5, or 48 root 5. I did it this way on purpose because I could have noted that it actually has a factor of 256, although that's very hard to see. So you could do this kind of the same way that you simplify fractions. You can divide top and bottom of a fraction by something, and if it's still not in those terms, do it again and again until it is. Same idea here. Keep pulling out factors until you're done. Okay, for part C, we're getting into the kinds of things we're going to be seeing more of in this unit. So I'm going to point out that the 6 doesn't do anything right now. Neither does the 2 on the bottom. Oops. I'm so used to using the quadratic formula. I put plus or minus there for no reason. 6 plus the root of 48. Well, the 48 is equal to 4 times 12, which is equal to 4 times 3. So that's 16 times 3. I can pull out a root 16 again. That becomes 6 plus 4 root 3 over 2. And then finally, I can make that even a little bit nicer by dividing all of the terms, top and bottom, by 2. Luckily, the bottom becomes a 1, so it's no longer a fraction. And that just becomes 3 plus 2 root 3, which is actually a lot easier to work with, especially if we're doing operations on it, than the original 6 plus root 48 over 2. All right, for number 2, here's a very useful skill that no one ever actually thinks about, and it's called rationalizing the denominator. And what it is, it's a way of making a radical on the bottom go away. We're okay with fractions that have um, integers on the bottom, but we don't really like when they have radicals on the bottom. So we're going to rationalize them, or make it a rational number, or a rational denominator anyway. The way that I would do this first one is to just say, okay, 6 over root 2. If I don't want the bottom to be a radical, just multiply top and bottom by root 2. And then on the top I have 6 root 2. And on the bottom I have root 2 times root 2, which is 2. And now I can divide top and bottom by 2, and that is actually equal to 3 root 2. So not only did I rationalize the denominator, not have a radical in my denominator, I actually made the fraction go away. That's pretty sweet. And those two things are exactly equivalent. If you don't believe me, you can always pull out your calculator and type them in. 6 divided by root 2 and 3 times root 2. They should equal the same number. Let's try the same thing on this one. We've got a couple of options here. I think what I'm actually going to do is I'm going to simplify the root 75 the same way I did the questions, or the parts in question 1. And that becomes 5 plus. Now I'm going to do this part in my head just to save a line. Root 75 is equal to root 25 times root 5. Root 25 is 5 root 5, so that's good. And this is still over root 5. And now what I'm going to do is the same trick that I did in A. I'm going to multiply top and bottom by root 5. And what that'll give me on the top is 5 root 5 plus 5 times root 5 times root 5. Well, the two root 5s go together to make 5, and 5 times that is 25. And on the bottom, root 5 times root 5 is 5. Now, every term here is divisible by 5, so I can simplify that a little bit into root 5 plus 5, and the denominator goes away. So 5 plus root 75 over root 5 is just 5 plus root 5, or root 5 plus 5. By the way, not too worried about the order in which those two things appear. Okay, the last one is by far the biggest trick, and the one that students tend to forget. If we want to rationalize the denominator in part C, we've got to get rid of the root 24, but multiplying by root 24 will not do the trick, because then it'll just give us a radical after the 3, even though it fixes the root 24 part. So what we can do is play a little trick with the difference of squares and say, multiply that by 3 minus root 24. That, by the way, is something called the conjugate. 3 plus root 24 has a conjugate of 3 minus root 24. And what happens is, basically, when you multiply them together, they act like a difference of squares. Now, on the top, we basically have to use FOIL or expand that out. So it's going to be 2 times 3 is 6. 2 times negative root 24 is negative 2 root 24. Root 6 times 3 is 3 root 6. And root 6 times root 24, negative root 24, is minus the square root of 6 times 24 is 144. And on the bottom, I'm just going to remind you that a squared minus b squared equals a plus b, a minus b. It's our difference of squares formula. And since the bottom is a plus b, a minus b, we can write that as a squared minus b squared. Okay, on the top, we can do a little bit of a cleanup. We have a 6. I'm actually going to do this in 2 steps just so we can fix a few things. The root 24 could be written as root 4 times root 6. So that's just 2 root 6 plus 3 root 6. And the root 144 is actually just minus 12. And on the bottom, we just get 9 minus 24. So on the top, we look at just the whole numbers. We got the 6 and the minus 12 gives us negative 6. Minus 2 root 6 plus 3 root 6 is plus 1 root 6. And on the bottom, I think we got negative 15. Now, I'm going to notice that the 6 and the 15 both have a common factor of 3, so it'd be really nice to divide, except the root 6 doesn't have anything. I will, however, say that since we've got a negative on the bottom and one of the things on the top's a negative, it's not a bad idea to multiply top and bottom by negative 1. Just to get on the top 6 minus root 6 and on the bottom positive 15. Which I think is the nicest way that we can actually write that, that fraction. Okay, that's it for the radical skills that I wanted you to kind of remember. There are a few other skills at the bottom there, things like simplifying expressions using exponent laws, but you've been using exponent laws since grade 9. Solving quadratics by factoring and using quadratic formula, you've been doing that since grade 10. Simplifying radical expressions we just did, and simplifying and solving log expressions and equations is something that we pretty much just finished doing last unit. So that said, try those homework questions. If you've got trouble, please notice or please recall that there is actually a glossary of terminology and prerequisite skills section under the textbook, so you can access those to read over any of the skills that you're having a little bit of trouble with. Other than that, I will see you in the first lesson, which we will be doing shortly. Have a great day.